All right, so here we are in 4.9. Our derivative work is complete. Give yourselves a hand. You're not excited? What's wrong with you?
Oh, great. That was a premature class, because I don't want to be clapping.
No, seriously, you're done with limits. You're done with derivatives. Now we practice for the next 3 months. 3.5 months. 4 months. Okay? The rest of the semester until spring break is antiderivatives. Okay? So, and this is how we can frame it. It's really not that difficult. You're going to be okay here. That's coming from somebody who's been doing calculus for a long time. Okay. You're very familiar with that function, I assume. Of course, I know that. What's the derivative? Okay. So that was a power rule, correct? So you brought the power down, or the exponent down, and subtracted 1. Okay. How would I go backwards? No, see, this is what antiderivatives are. We're going backwards. All right, so antiderivative. Okay. So how would I take that and make that up? No. You could, but it doesn't always work that way. So I'm trying to kind of give you your first antiderivative with you figuring it out. How do I get from there to there? Okay, so, you brought the exponent up. Fantastic. But how do I deal with that number? Divide by your new exponent. Right? Because that makes x squared. Okay? So we add 1 and divide by the new exponent. Okay. We have to do that because all right, so there you go. No, this. So we should get the answer back, right?
So this is just to take you from like F prime.
Yeah, we're going from F prime to F.
Could you do that with
Okay.
like F double prime to F?
Yeah. Yeah. It's an antiderivative. So wherever you are, you're going that direction. Okay. So let me give you another one that you know. A derivative these are the only two we're going to worry about today. What's the derivative of natural log? Yeah. Oh, boy, I just did that, didn't I?
So if you get
Okay, so what is the antiderivative of 1 over x? There's just one little caveat there. You have to put the bars. Okay, so.
how do you find that? Yeah, how did you get to that?
Derivative?
Yeah.
antiderivative.
So you just have to memorize that?
Yeah,
You just have to-
basically.
that's what you just have to know?
You know the relationship. Okay, so, okay. Is natural log defined at negative numbers? Now, if you look at a graph of the natural log, right, no negatives. Okay, so, but 1 over x is defined for negatives, right? So we're okay going this direction, but going backwards, this has negatives, we have to exclude them or take care of them in this. So we take care of them with absolute value. Okay, it works. It's interesting how it works. Yep. Okay, so those are the two we're looking at today, and I want to give you kind of a more formal definition of an antiderivative, but that gives you an idea of what an antiderivative is, right? So here's the formal definition. Let's see if we can decipher it. A function big F of x is an antiderivative of f of x on AB. It's an interval if f prime, big F prime of x equals f of x for all x in the interval. Okay, so this just presents it. Right, this is the formal definition of it. Okay. Bummer.
Hey man, go.
Go then. So this just puts it in a different format than you just saw. So f is the antiderivative. So if I went back here, this would be big F of x on the end. This is the antiderivative, right? And this is f. Let me write it in red. So in the definition, this is what we're looking at. Big F is the antiderivative. And it says f prime, big F prime, is equal to f, right? So if you take the derivative of big F, it's 1 over x, correct?
Oh.
That's the relationship this is pointing out.
That makes sense.
Okay.
Oh.
Does it make sense?
Later, yeah.
Brandon, does it make sense? Sometimes it takes you a little bit. Okay, so the definition puts this as the antiderivative, and it defines it in terms of f prime being the original. Okay? So that's kind of the formal definition. Do you necessarily need to have that memorized? No, but you need to be exposed to it for formality's sake for your future work. Okay, we have to be very careful. Because I kind of shielded you from this at the first. If I give you f of x equals x cubed over 3. What is the antiderivative? Okay, this is how we write it. This is how you're going to be asked of it. Okay. Calculate the antiderivative of x cubed over 3. That's this sign here. Okay, that's what that means. We're gonna we'll change that word a touch here in the next couple days, but for now you can just call that an antiderivative. Okay. Mm-hmm. Okay, based on your knowledge of the power rule, for antiderivatives, what do I do to the exponent? Okay. Divide by the new exponent. So this is actually 3 times 4 now. So I added 1 and I divided by the new exponent. It's the same thing. If you did fraction division, it would all work out. Okay, so now here's where you have to be a little bit careful with antiderivatives. We have to add a constant. Okay.
Only when they're in a fraction?
No. Anytime you take an antiderivative, you have to add a constant. Okay. Now why? Think about it. What if I take the derivative of this? What's the derivative of any number? 0, right? It drops away. So this could be 5, right? But it could be 10. It could be 5 million. So the problem there is it shifts the function up and down, and it changes the meaning of this. So for now, just know if you have an antiderivative, you add a constant. Okay. Because I was giving you the introduction to it. Okay. Yeah, I was shielding you. I wanted to directly relate it to derivatives, so okay. There you go. Okay. We don't know the number. Yeah. I will give you some tools to figure that out later. It's really not that difficult, but do I say that a lot? It's not that hard.
Yeah.
Does it drive you crazy?
Yeah.
Okay, I'm sorry. I'll keep saying it. I mean, stop saying it. You can multiply it as 12. Okay, thank you. It's not something that you need to really be worried about at this point. Okay, here's a little more. Five thirds plus. Okay, so you might see something like evaluate. Okay, probably that. Not going to bust your chops about it. Okay, so antiderivative of 3x to the 4th. We just do these one at a time. Okay, just do them one at a time. It's just like derivatives. So what's the antiderivative? Over 5. Five x. Now add 3 over 3, because that's 1, correct? 5 thirds over 5 thirds. Got a little fraction math to do, which is okay. Add 1. Plus c. Okay. You've done the calculus. Now you can simplify it. You should. No. And I would say you shouldn't. Nice try.
That was boring.
What have I told you? Practice it now in case you need it later.
Yeah.
Okay, how do I deal with a fraction in the denominator? Yeah, it's fraction division. So copy, and you flip. So dealing with these, the 5s cancel, right? So there's your answer. Okay. So you got it. Now think.
What would that be?
What? Oh, it's 3x to the 5/3.
Okay.
Yeah. Okay, now get in the habit of checking. Okay, what's the derivative of this?
The whole thing?
Yeah. Derivative, you bring the 5 down, right? Subtract 1. So 5 times 3x to the 4th over 5. And you can see why we have to divide by 5 now. And we get our original. Yeah. Now what's this one? Bring the 5/3 down. X and then subtract 1 to the 2/3. And what do we end up with? Our original. That's why we have to do that division. Okay. And then this one. Wait, hold on. Bring the -2 down. Subtract 1. Okay. See, those cancel and the negatives cancel to give us a positive. And what's the derivative of C? 0. Okay. So you can see how this is working both ways. A lot of really smart people put a lot of time into making sure these were done right. Okay.
Do you want us to check every single time?
No. You don't need to, but you can. Okay, one more. With natural log.
Oh.
-10. No, it's just a symbol. That means antidifferentiate. It's not a Greek letter. Okay. A lot of times we use those, but not this case for some reason. Okay, so do you remember what the antiderivative of 1 over x is?
Natural log. Absolutely.
Yep. Oop, I added a slide. So 5 natural log absolute value x. That's this. And then minus, what is that? We're missing something. Okay, there we go. You got it. Okay. You can simplify that fraction if you want to, right? Yep. That's it for today. This is your introduction to antiderivatives. Oh, bother.
That's what I'm saying. It is a bother.
I know.
I can find his afterwards, I have to get up at 6 something tomorrow on like Saturday. He has to get up earlier.
I'd be more fun with this than getting up at 6 o'clock.
Love anybody be like,
Yeah,
we're here at 2:30.
I'm writing down all of it for the next several days. So and okay, one more line.
I wish it would break.
Then I give you more.
No, that winter break went by so fast. Yeah, faster than it ever has in my entire life.
It went by slower for me than anything else.
Well, I wish it would've
Okay,
been.
this is a 3-day section. Okay, so day 1, this will match. Day 2, day 3, spiraling. You have until next
I'm doing that.
Thursday. So quit complaining, or it's going to be due on Tuesday.
Hey now, hey sir. Well, I know what I'm doing. Can you come here when you're all done? Yep.
Of course I can.
Naturally.
Is it math related?
Yeah.
Okay.
But it's also not for this related, but it's for
Chemistry. Oh, I looked through that book last year. It's too easy. I'm just kidding. Chemistry, I think, is
Okay, so this
hard.
is our equation, and those are our numbers for our variables, right?
I don't know.
Okay, are we supposed to distribute this first or multiply
It
and
doesn't
then
matter.
distribute? Well, everybody was getting 40 different answers yesterday, and we kept fighting, and nobody could figure it out.
Well, if you distribute this in,
Uh-huh.
then you have to distribute that in too. So
Well, she didn't tell us that.
put those, just multiply them together,
Uh-huh.
then distribute.
Okay,
Easy
but
way.
she said that was wrong.
She said that that would give you the wrong answer.
This is multiply, right?
So I
Yeah,
was
that's
so
time.
MC, change in T,
Uh-huh.
Yeah.
and this is Fahrenheit to Celsius.
No, it's some. There was no.
Oh, heat capacity.
Yeah, the specific heat.
Oh,
The final
I see.
temperature for
I see.
that block with this specific heat. I don't really know
How do you
why,
know?
because that was the question, and I don't
Oh, I
understand why we
see.
have the F.
You're calculating F.
Yeah.
It's solving an equation.
Oh yeah, because that's your other.
Yeah, multiply them together, distribute, solve the equation.
Okay, thank you. We were right. We were right.
Of course you were right. You're in calculus.
Thank you.